In this video, we are going to go through naming different types of compounds. So I assigned you various compounds to name or give the chemical formula of. The first step in naming a compound, so we'll work with this first one here, is we need to identify what kind of compound it is. And it consists here of a metal and a nonmetal. So this is classified as an ionic compound. And when we're naming an ionic compound, we first want to write down the name of the metal. So in this case, the name of the metal is silver. And the nonmetal is, in this case, a polyatomic ion. And if you look at your list of polyatomic ions, NO3 minus is nitrate. So the name of this compound is silver nitrate. Number 2, now we are going to give the chemical formula of sodium cyanide. And we know that's an ionic compound. Because sodium is a metal, cyanide is our polyatomic ion, that is our nonmetal. The symbol for sodium is Na, and Na has a +1 charge. We know that cyanide is N with a negative, Cn with a -1 charge. Since sodium is +1 and cyanide is -1, we don't need to change any of the subscripts. So we can leave it as NaCN. In the third one, we are to give the name of AlPO4. Al is a metal, it's aluminum. PO4 is a polyatomic ion. So we have a metal and a nonmetal, so this is classified as an ionic compound. And in ionic compounds, we name the metal first, which is aluminum. And this polyatomic ion, PO4 3- is phosphate. So we are left with this being called aluminum phosphate. Number 4, we have a hydrogen in front and AQ, which means aqueous, dissolved in water. So this is indicative that this is classified as an acid. And whenever we have an H and it's with a polyatomic ion, we're going to take, in this case, SO4, polyatomic ion, which is sulfate. And according to our rules for acids, X becomes ic. So we'll rename this as sulfuric. And we have to put acid as the second part of naming this acid. So the first step was identifying that this was an acid. Since this was an acid with a polyatomic ion, 8 becomes ic, so now it's sulfuric, and then we always have to end with an acid. In number 5, we have barium, which is a metal, hydroxide, which is a nonmetal. So this is classified as an ionic compound, and since we have a hydroxide, this is also classified as a base. We know that hydroxide is OH-. And barium has a +2 charge. So we need to make sure that this is neutral. So if I have barium with a +2 charge and OH with a -1 charge, I can crisscross so that the superscripts become now the subscripts on the other element or other ion. So now it becomes Ba parentheses OH2. Whenever we have more than one polyatomic ion, we have to indicate the number or the amount of that polyatomic ion with the parentheses and the proper subscript. So the answer is Ba parentheses OH parentheses 2. In the next problem, we have ClO2. This is not an ion. This is classified as a molecular compound because it's consisting of nonmetals. And since it's a molecular compound, we have to use prefixes. Since there's only one chlorine, we're going to leave it as chlorine. And since there's two oxygens, we have to use the prefix di, which means two. And oxide is going to represent the oxygen. So the answer to this is chlorine dioxide. Going on to our next problem, we have nickel 3 sulfide. Here we have a metal and also a nonmetal. So this is classified as an ionic compound. We're going to go ahead and first write our symbol for the metal, which is Ni. And we know that it has a +3 charge. And sulfite is SO3 with a -2 charge. Okay, so we have Ni3+ and SO3 2-. To make this electrically neutral, we do our crisscross method, and we're left with Ni2 parentheses SO3 3. In problem number 8, we have a hydrogen front with a polyatomic ion with aqueous. So we know that this is an acid. And we know that NO3- is nitrate. And according to our rules for naming acids, 8 becomes ic. So now this is nitric acid. In our last problem, we have ammonium carbonate that we want to give the chemical formula of. This is both nonmetals. We know that ammonium is NH4+. Carbonate is CO3 2-. So if we put this together, we can still apply the crisscross method. This -2 charge from carbonate applies to both the carbon and the 3 oxygen. So we're going to do the crisscross method, and since we need 2 ammoniums to balance the -2 charge on carbonate, we're going to put a parentheses with 2 as a subscript around our ammonium and CO3 as our carbonate. So that is the chemical formula for ammonium carbonate.